Hi everyone. These sessions or videos will be based on the assignments given in the course called Linear Algebra. It's Introduction to Linear Algebra basically. It's first year BSMS course at ICER Pune, and the course is taken by Professor Debago Banerjee, the first half, and the second half, Professor Vivek. So, my aim is to discuss the problems or the assignments what they will be giving to these students. And I think it would be better to share the solutions with student and as well as to the general public so that they can practice little bit questions. So I will not take too much of your time on these things, so let me directly begin with the problems which is for planned for the assignment one. Okay, so let us begin with the first problem. So you have given a matrix A in M2R. So let us recall or see what is this M2R. So M2R is basically, guys, all square matrices of order 2. So A11, A12, A21, A22. Is it all? No. These entries, these entries should belong to where? These entries should belong to real numbers. That's why R, M for matrix, 2 for the order is 2 cross 2. So for every I, J running from where to where? 1 to 2. I hope this is clear. Okay. So, you know, um, I will just say it out. So I will not write it. So you can think, you can define always a matrix as a rectangular array of m rows and n columns, right? M cross n matrix. But you can also define it using functions. Actually, a matrix you can visualize as a function. So this is something, for the interested people to think about. Now, so the question says recall the definition of when you call a map from R2 to R2 linear. So it's said to be linear. Now who already knew a bit amount of linear algebra, so be patient. We are starting. So we are defining things slowly and slowly. I would not prefer here to call it R linear. So right now, apart from this terminology, we are just using this term linear. Okay. So what's the definition? You should have two things. Sorry. If number one, if you take any two points or any two vectors in R2, so x bar, this is the notation what we are following. So I will stick to that. And I may ignore these sub bars. So forgive me for that thing. But yeah, I will try to, not do that. So yeah. So if you have two vectors and you add them, basically 2 points in R2, you add them, basically addition is component wise, then what you should get, you apply F to it, and it should be same as you individually apply these F to X and Y, and you sum these. Number two, so if you take some lambda and some vector x, basically you are multiplying this lambda to each and every component of x. So it will have two component, right? It's in R2, Cartesian plane. So lambda, say x1, x2, so lambda x1, lambda x2. So what you should do, you just compute this quantity. You apply f to the x lower bar and have lambda here. So this you should have. So this is for every x bar, y bar in R2 and lambda in R. Okay. So if you don't recall what is this bold R means, real numbers. I think I have said it. Okay. So what is your task for this problem? Let us see. So your task is basically to prove some map. So the question is, in other words, they say the function preserves vector space structure on R2. Okay, yeah, this I think you might have learned in the classes. This is for the students, and if others don't know what I mean by this, then they can look. There are plenty of good books available. For example, Fredberg. I personally recommend that for a very first course. So what we have to show, we have a map from R2 to R2. What is the map, guys? So I have this fixed matrix and I'm defining some map. If I take an x bar in R2, what you do this matrix multiplication. So the task, what is the task? The task is to show that f is linear. Okay, so let us see how we can do this. So first of all, before proceeding to linearity, we have to understand what is this map, what it actually does. So for simplicity, you assume your A to be whatever notation you want. Let me do the standard notation. And your X to be, say, X1, X2. It depends like how you write things row wise, column wise, however you want to write. That's your decision. But note that if this is 2 cross 2 and you're multiplying it here, right? So it should be 2 cross 1. That's why I have written 2 rows, 1 column in this, what you call, column wise X. Okay. Now, what you have to show, this is linear. So basically you have to pick two members from R2. So correspondingly, okay, we haven't seen how we are defining this map. So yeah, let me define here. So what it is basically, this is A11, A12, A21, A22 multiplied with X1, X2. Now, you know how the matrix multiplication goes? You have this, you multiply by this, right? And what would be your, this is 2 cross 2, 2 cross 1. So the result should be 2 cross 1, right? So you multiply it. So what you have is, so A11 x1 plus A12 x2. This is your first element, and another one is A21 x1 plus A22 x2. Right? That is what the definition is. You can write this in a concise manner also if you want. So let me write like this. You can write it as a like matrix. I can use, these kind of brackets or these kind of brackets. Both I will use to represent matrix, so don't get confused. So, yeah. So what you can do is you can write it like this. So if you have observed what is happening, so you're varying like this row wise. So your which index is fixed? Say first index is fixed, right? And you're varying what? The second one, say J. And it is running from 1 to 2, right? There are two columns. And this also you are varying, right? So this is what? Xj. Correct? Similarly, the other entries j equal to 1 to 2. Now you are on to the second row and you are varying column. So in a very concise manner, you can also write like this. So it is just the matrix. Yeah. So j is from 1 to 2 A I J X J. So, yeah. So that's how you can also write. So you can mention it 2 cross 2 to see like where I is varying. I is also varying from 1, between 1 and 2. 1 and 2 only. Yeah, the natural number 1 and 2. Okay. So I will use the both of these notations and give you a proof of the linearity. Okay. So now let us begin. So let what you have to assume, not the upper one. Yeah, this notation of bar I usually don't use. So it belong to art. So they will be like how? Right, we have written x1, x2. Y will be y1, y2. Please forgive me if I forget to write these subbars. Okay, now what you have to see, you have to compute this quantity, right? X lower bar plus y lower bar. And you have to show it is f x lower bar plus f y lower bar. So let us see what it is. So you can write like this in a matrix notation if you want. Y1, y2. And what it is, guys? This will be nothing but x1 plus y1 and x2 plus y2. Now this is your, you know, the point where you have to apply A. So in place of x1, you have this whole thing. In place of x2 there, you have this whole thing. So by definition, what it would be? Let us see. So it would be A11, sorry, x1 plus y1, A12, x2 plus y2, A21, x1 plus y1. I'm just replacing the role of xi's. We have new point of R2 where we have to apply, right? New vector of R2. So A22, x2 plus y2. Hmm. Let us see what is this. Now we want, to write it as fx lower bar plus fy lower bar. So separate xx things, separate yy things. Distributivity, associativity, commutativity, everything works under addition, right? So what it would be, guys, I'm writing directly A11 x1 plus A12 x2. You can verify plus A11 y1 plus A12 y2. And similarly, what you have here, sorry, A21 x1 plus A22 x2 plus the similar term A21 y1 plus A22 y2. Now you see, you know the matrix addition, right? So it's a 2 cross 1 matrix. So if you have somehow you sum it, you sum each and every corresponding entry of the matrix, right? So if you have some matrix A, which is denoted by say entry Aij in general, and this is Bij. So what is the sum, guys? Aij plus Bij, corresponding order, whatever it is, right? So what it would be, you can now split it like this. A11 x1 plus A12 x2, A21 x1, A22 x2 plus A11 y1 plus A12 y2, A21 y1 plus A22 y2, right? Now guys, compare with the definition of f x lower bar. What is this? If you compare it properly, the first one is what? F x lower bar, and the second one is, sorry, by mistake I've written G, F y lower bar. So you have picked, arbitrary points, right? Be arbitrary also you can write. So what you have shown for every x bar and y bar in R2, you have this property for any 2 points. So you have done the first property. And the alternative way in the other notation, if you remember, so what was that notation? So f of x lower bar, recall it. So it was the matrix j's from 1 to 2, aij xj, right? This is the general entry of the matrix. So for having the first row, you have to put I equal to 1, right? And for having the second row, you have to put I equal to 2. Let me use the single bracket. Yeah, I told you for matrix, I can use curly bracket also and the square one also. So don't get confused. I'm saying it is a matrix. Yeah, let me write like this. Although I've written order here. So this should not confuse you. Okay. So in this notation, if you see this, I will quickly do and you can, then verify the details. This will be, this all you have to verify, huh? You have to use this definition and you will get it. Then can I just directly write this? Please try it with this notation. Similarly, the other property also I will do for the expanded version. You try to write in a compact manner. See, it's always important to write a neat and clean proof. So the neat and clean, by that I don't mean your handwriting should be very beautiful. It should be something which others can understand. That's all. So neat and clean is a compact argument. So this will be a like very compact way of doing things this way. So that's what I'm leaving to you. And the justification for all of this, see, I'm giving you here all detailed justification, right? So now let us do the second property, which we have to verify. So let us take a lambda in R and x lower bar in R2, arbitrary, be arbitrary. Now you know what you have to start with. You have to start with f applied to lambda x lower bar. So what it is? By definition it would be lambda x1, lambda x2. Now what it is? You know the definition, right? So a11 lambda x1, right? Plus a12 lambda x2, right? a21 lambda x1 plus a22 lambda x2. If you don't remember definition, that is fine. You can always multiply two matrices like we have done above, right? Now you see, in the first one, you can take lambda common. Sorry. Yeah. a12 x2. And the second row also you can take lambda common. a21 x1 plus a22 x2, right? Take this lambda out and whatever you get, I'm not writing, please write it. This will be lambda fx lower by the definition what we have expanded. So this is what you have to show. You have to show these two properties, right? We have shown all of these two properties. I hope this question is clear. Now what you guys should do, ideally, this is a 2 cross 2 matrix, right? Try what happens for a 3 cross 3 matrix. Try what happens for a 4 cross 4 matrix. And if I give you n cross n matrix, then writing like this square brackets will become, very complicated. So which notation will come handy? This one, the compact notation. Okay. So do with this notation also this proof. Try to write it. If you are unsuccessful, then you can always discuss with people, me in comments, and you have various sources. Yeah. Okay. But don't do chat GPT and all, okay? Now, Second problem. In second problem also you have given some functions from R2 to R2 and you have to verify if they are linear. So let us begin with problem 1. If x comma y is equals to e to the power x comma y. So these maps are from, I'm again saying, R2 to R2. So now they are writing a point of R2 like how? Like x comma y here. This x comma y belongs to what? R2. Okay. So we have to see if this is linear or not, right? Okay. So let us see how we can proceed. So there are two properties, right? What are the two properties? One is the addition one, another is the scalar multiplication one, like lambda into x lower bar. Okay, so let us try to see what is say x comma y. I just let me begin with this thing. So what it would be? So it would be lambda x, lambda y, and we have to apply f to it. What it is, guys? E to the power lambda x, lambda y. Can you take this lambda common? Meaning is this is equal to this thing, lambda e to the power x comma y. What do you think? If you have no clue, or you might have guessed, right? You cannot take. So what is the simplest? So this is not the proof, right? You have to check if it is linear or not. So you have to do for a fixed value of lambda. Maybe for some particular lambda this is true, right? It is possible that for some particular lambda this thing is true. So let us take, for example, the simplest one. What is the simplest one? 0. Now you will ask me why you have taken 0 and all. See, it depends upon the experience. It's a hit and trial. You will also learn it soon. Okay. So let us do it with 0. So what is 0x comma y? This is, guys, f of 0 comma 0, right? And this is what? This is nothing but e to the power 0 comma 0, which is what? 1 comma 0. Okay. Now what is 0 into fx comma y? So it is 0 into e to the power x comma whatever it is y, right? By definition. So what is this, guys? This is 0, right? So 0 you have multiply, everything you will get is 0. Oh, see, f of 0 comma xy is not equal to 0 comma f of xy. So f is not linear. I want to give a homework. Please try to check. What about this? A comma b, if I take 2 points in R2. What about this? Question mark above equality means I'm asking you if this is true or not. This is your homework. So let's say if this is true and you are trying it for the first property, then you will say, oh, then we have to go to the next property to see if it is true or not. If this property is false, then from there also you can conclude, that this function is not linear. Right? Now let us do some more. So another part, B, if x comma y, a similar function, sine of x comma y. Let us see. Let us see, huh? Okay. Now, so if you take, for example, again, this one. See, scalar multiplication is bit, easy to check. then the addition. So that's why, always begin with this kind of thing. So, okay. So f of lambda x comma y, let us see what it is. F of lambda x comma lambda y. And what it is? Sine of lambda x comma lambda y. Can you take this lambda out? No, right? You haven't learned any such property. But for some number, if you know, maybe 1, of course, lambda equal to 1, minus 1, maybe. Think about it. So let us again here take some particular, choice of points. So again, your choice should be very simple, guys. So for example, if I take lambda equal to pi, for example, and I take x comma y equal to 1 comma 1. So let us see what is f of for this value pi 1 comma 1. So this is by definition sine pi comma pi. What is sine pi, guys? It is 0. Okay. Now let us compute this quantity 1 comma 1. So what it is, guys? Pi into sine 1 comma 1. This is pi sine 1 comma 1. Oh, is sine 1 0? If sine 1 is 0, then these are equal. But let us see what is the graph of sine. I may not do make a very good graph, but yeah. So sine 0 is 0, sine pi is 0, 1 is somewhere here, right? And the graph, is like this sine. Not maybe here. Pi by 2 is, yeah. Somewhere here 1 you have, right? So definitely on 1 strictly lies between 0 and pi, right? Pi is your 22 by 7, 3 point something. And in all this region, the sign is strictly bigger than 0. So this is not equal to 0 comma 1, which is f of pi 1 comma 1. So again, you may ask how quickly I have chosen the points. The reason is you will learn it from the experience. So similarly, check if the x plus y, the two points if you take in R2, that additivity one property, does it hold? Again, that is your homework. Okay, nice. Let us now do further another thing. So third, f of x comma y is y to the power 5 comma x. Oh, wow. Let us see. Okay. So again, I will always, I like to use this property because this is simple than addition. And if this is satisfied, then we have to definitely go to addition. So what it is, guys? Lambda to the power 5, x to the power 5, comma lambda y. You take lambda common. Okay? And what you will get? Lambda to the power 4, x to the power 5, comma lambda y. Oh, sorry, comma y. Now you will say, oh, wow, we are taking a lambda common out. So it may be linear. But no, check it. So this is lambda. Fxy is y to the power 5. X to the power 5. Can these things be equal? Not always. Like if you take lambda equal to 0, right? It is always equal. So what we have learned, a fact, which you might have done in class or in theory, that if f from R2 to R2 is linear, this will implies f of 0 is always 0. Why? Because you can always take your lambda to be 0 and any other point. So you will get this because it will be 0 into some x lower bar, which will be 0 into some. So here 0 means 0 comma 0, this 0 bar lower bar, and this one also. And here this is yeah. So how this is coming? Because this is the vector 0 bar. right? And this is, if it is linear, then this will happen. And this is what 0 into anything is 0, So F0 lower bar is actually F0 lower bar. 0 into any vector, right? The same property we are using because of linearity. Okay. Oh, is it true for any Rn? What about Rn? Here n equal to 2 was there. So think about it. Okay. So let me return to the problem. So definitely these two things, look different. So let us take some points again. So take some lambda to be non-zero, because if you take 0, you see 0, 0, it will become. So say lambda equal to 1. You should always take simplest value. But will this work? See, if lambda equal to 1, the point is same, right? So maybe something. Say lambda equal to 2. And point say 0, comma 1. So let us see what is f of 2, 0, 1. This is f of 0, comma 2. And what it is, guys? So by definition, this is 0, comma, 2 to the power 5, whatever it is. 2 into 2, 4, 2 into 2, 4, 4, 4, 16, 16 into 32, I guess, 0. Because this number, you have to do power 5. Okay, and what is 2 into f of 0, comma 1? This is just 1 to the power 5, comma 0. So 2 into 1 to the power 5, which is 1, comma 0. This is 2 into 0. So clearly, these two are not equal, right? So you see, this is also not linear. So similarly, you can have, various other functions we can give you and ask you, oh, is this linear? Try to do it for all functions, like try to do, for example, fx comma y, you can define, say, log x comma y. What about this? Is this function linear? Okay. So I hope this is clear. Okay, let's proceed, guys. So this is your question number 3rd. So you have given up two vectors v bar 1 minus 2 1. You have given some w bar 0 1 minus 1. So you have to find these two real numbers, find C and D in R such that, let us see what, C v lower bar plus D w lower bar is equals to 3 3 minus 6. Let us see, guys. So basically, we have to do this scalar multiplication thing here. So C will be multiplied with the each and every element. So C1, let us compare both sides, right? Compare both sides. So what you will get, C1 minus 2, 1 plus D 0, 1 minus 1 is equals to 3, 3 minus 6, right guys? Solve it. This will imply you know how to multiply and add, right? So first it will be multiply, meaning C for the first component, then add it to the first component, which is 0. Then minus 2 C. Okay, let me do step by step. Plus 0 D minus D. This is equals to 3, 3 minus 6. Okay. And what is this, guys? So now C, you add it. D minus 2C, comma C minus D, right? Is equals to 3, 3 minus 6. Oh, two tuples. 2 points are equal if and only if they're equal at every coordinate, right? So what you will get? C is equals to 3. Oh, okay. And D minus 2C is what? 3. So let us substitute your C here. So what is this? D minus 6 to 3, meaning D equal to 9. Okay. But there is one more component, right? Maybe this value of C and D doesn't satisfy that. So you should always check, is C minus D equal to minus 6? Let us see. So what is a C is 3 minus D, what is a 9, which is equal to minus 6. Yeah, no problem. No problem, right? So if I change this minus 6 to be, say, 100, can you find such C and D? What I'm saying? If I change minus 6 or replace with 100, then no such C and D exists, right? Because whenever you have this, the difference should be, of this should be minus 6. And you are saying minus 6 equal to 100. So, yeah. So, what is the value of C and D? We can write finally. So, your answer is C equal to 3, D equal to 9. Nice, no? Okay, very nice. Let us proceed to the next problem. Yeah, I am very lazy at such problems, but it's okay. We have to do because you have to learn matrix multiplication. Okay, so what is your A? A is 1, 2, minus 1, 3. See, in general, how we write matrix multiplication. So say this is ijth entry. Say this is ijth entry of B. Say this is m cross n, and this is, say, n cross n. Okay. So what you do is, guys, you have to take a row like this, right? From A, and you have to multiply by a column like this. So ijth entry, so for ijth entry, you will take ith row. This you will take the jth column, right? So when you multiply this ith row and jth column of B, and then you have to vary here what columns. So k will vary from where to where? 1 to how many columns are there? N. So you should have n rows because here you are varying n rows. That's why you always need, order m cross n, n cross m. So this will be a general entry for your matrix. Which matrix? A into B. So this is how an entry looks like. Sorry, I made it n, but it was k, right? Clear? If it is not, definitely you can ask. So, but here the question is much simpler. What you have to do, you have to find in question a square minus 2a. Let us see. So a square, let us find out what is a square. So 1, 2, minus 1, 3. 1 minus 1, 2, 3. So this with this first. So 1 into 1, which is 1, minus 1 into 2, which is minus 2. This is the first entry. Second, 1 into minus 1, which is minus 1, then minus 1 into 3, which is minus 3. Similarly, 2 into 1 plus 3 into 2, 6. Minus 2 plus 9. Whatever this is, let's see. We have to solve. I'm very lazy at this. So minus 1, minus 4, 8, 9 minus 2, right? So I hope I'm doing calculations fine because I'm horrible at calculations. So yeah, let me check once. 2 plus 6, yeah, that is 8, and 9 minus 2, that is 7. Similarly, what do you have to do? Minus 2a. So what is minus 2a? Multiply minus 2 with each and every element of this matrix. That's the definition. So minus 2 into 1 is minus 2. Plus 2 because it's minus 1 into minus 2. And then minus 4. And then minus 3 into 2, 6 minus 6. So by 1 and 2. So what you will get from 1 and 2? So from 1 and 2, you will have, sorry, a square minus 2a to be 2a to be -1, -4, 8, 7, plus -2, +2, meaning 2, -4, -6. So how you add two matrices? Entry-wise. So -1, -2 is -3. -4 +2 is -2. 8 -4 is 4. 7 -6 is 1. So this is your answer. That's all you have to do, right? So let us do the next part. So B. So in B, what you have to do, you have to compute this quantity, 3a cubed minus 2a square plus 5a plus 4i2 or minus 4i2. Doesn't matter, it will be a new question then. So what is I2? I2 means identity matrix. Basically 1, 1, here 0, here 0. The diagonal entries are 1 and other than that, everything is 0. Okay, we have already computed A. We have already computed A squares. So what will be A cube? This will be A times A square, right? So let us write A again. 1, -1, 2, 3. Let us write A square, which we have computed above somewhere. So it was -1, -4, 8, 7, right? No, you just have to, multiply these two things. So let us multiply. So 1 into -1, this is -1. -1 into 8, -8. Wow. So 1 into -4, -4. -1 into 7, -7. 2 into -2, -2. 3 into 8, 8 into 3, 8 to 6. No, I don't know what it is. What is it into 3? 24, I guess. And this is -8 plus 7 3 is a 21. Sorry, 21. My God, this I don't like, so many calculations. So -9, so that's why soon I'm gonna give you a homework, maybe. So -7 plus 4 -11 is 22. This is 21 minus 8. How much you get? I seriously don't know. So 20 minus 8 is 12, and you have one more, so 13. So you have a cube. See, you have a cube, substitute it here. You have to compute minus 2a square. You already have a square. You have this also plus 5a. What is a? 1 minus 1, 2, 3. And then minus 4 into 1, 0, 0, 1. So I want to find this, right? So let us find. So 3 into this matrix. Each and every entry will get multiplied. 3 into 9, 27, I guess. Minus 33. This is what? 22, right? So 3 into 30, 66. So 9, 3, 39. If I'm doing calculation mistakes, please forgive me. So minus, you can have this -2, multiply -2 inside, or have minus here and just multiply 2. One and the same thing. Let's multiply -2 inside. So that is -2 into -1 plus 2. -2 into -4 plus 8 minus 16 minus 14. You can verify. Then plus multiply this 5 minus 5, 10, 15. So minus, let's write minus here. So this will be 4, 0, 0, 4. Otherwise, you can write just -4 directly. And I am just doing first entry, not even solving it. So what will be first entry? First entry of each and every matrix, right? Sorry, not +4, -4. That's all you have to do. So what is this? What is this? What is this? This is a homework. Okay, very nice. I have a very urgent message. I will just quickly look at it. So yeah, okay, I can ignore it for the moment, and I can move on to the next problem, which is problem number whatever. I think, yeah, 5. So fifth. Now, guys, so we have to find or determine this lambda in R such that we have given ax bar is equals to lambda x bar. Let us see what is A. A we have given 2, 1, 1, 2. What a nice matrix. See, Here 1, 1, 2, 2. Something you will see later on. And x lower bar is 1, 1. Just we have to figure out the value of lambda. So again, what we will do solve both sides and compare them. So 2, 1, 1, 2, 1, 1. And this is lambda, lambda, right? And I have directly multiplied it. So this is what? 2 into 1, which is 2 plus 1. 1 into 1, right? So 3. And this is also 3. Oh, wow. See? So easy. So this will imply lambda is equals to 3. Now what should you do? You can take higher order matrices, you can take other matrices, and you can take different x and try to see if you can have some lambda or not. Might be possible that you cannot figure out what's the value of lambda. You will see later on, you will study all those things. Okay, now let us come to the final problem. You have given a equal to cos theta, sin theta, minus sin theta, cos theta. This is one of the most important metrics. Important. One of the. This one. In geometry, algebra. So this is very important example. I'm not disclosing it now. Soon I will be, maybe I will disclose it. Or eventually you will learn when you will take higher courses. So what you have to determine is A, you have to find A square. B, you have to find A cube. And C, you have to find A91. Oh my God. Oh my God. Meaning you have to multiply this matrix 91 times. Okay, let us see. Oh my God, 91. I'm scared now, really scared. So let us see what is A square, huh? Step by step. My God. Minus sine theta, cos theta, right? Into this only. Cos theta, sine theta, minus sine theta, cos theta. Now let us solve this. So cos theta into cos theta, that is cos square theta plus this thing. So this is cos square theta and this is minus sine square theta, right? And yeah, then the other one is cos theta sine, sorry, yeah, sine theta plus this sine theta cos theta, right? Okay. And this is, if you see this thing with this, now this with this. So this is minus cos theta sine theta minus cos theta sine theta. Okay. And then the last thing, again, cos square theta minus sine square theta, you can see. Use your trigonometric identities. I am not very familiar with trigonometric identities, so let me write it because I always forget. Cos A plus B. What is cos A plus B, guys? This is cos A, cos B, minus sin A, sin B. Wow. What is cos A minus B? You can write. I don't need it, I guess. So what is sin A plus B? Sin A cos B plus sin B cos A. You see here, here, and compare these terms. So this is theta. A is equal to B equal to theta in this case, right? So what this thing will become? So this will become cos 2 theta, right? This identity. Similarly here cos 2 theta. And what it is? This identity, no? So this is sine 2 theta. Oh, but here you have minus. Take it common. No issues. So this will be minus 2 minus sine 2 theta. That's all. Okay, this is, your A. So I will be using these identities now. So let us see what is Q. So A cube will be A into A square. Okay, what is A? Cos theta, sine theta, minus sine theta, cos theta. And you have already computed this. Use the part A, sine 2 theta, minus sine 2 theta, cos 2 theta. Okay, very nice. Let us see what it is. So, matrix multiplication again. Cos 2 theta, minus sine theta, sine 2 theta, right? You will get the same term when you do this thing with this. So, you know the pattern now, right? So, cos 2 theta, minus sine theta, sine 2 theta. You can verify it. So, now this with this. So, what you will get? Cos, this will the second one, right? Cos theta, sine 2 theta, less, right? No, minus. No, plus. Plus sine theta, cos 2 theta. Similarly, you will have just minus. This is like same kind of matrices. Just a second, I'm busy for a moment. Give me 10 to 20 minutes. Okay. So what I have, Rishabh, I cannot now. Okay. Sorry for the disturbance. So what we will have just minus of that cos theta, sine 2 theta plus sine theta, cos 2 theta. Now again use your trigonometric identities. The same. So what you will get here is cos 3 theta sine 3 theta minus sine 3 theta cos 3 theta. Now the next task is to find what is a to the power 91, right? Okay, let's do the mini step. So a into a4. I'm leaving the calculations for you. What you will get is this. You can observe this. So, yeah. Now, have you noticed something? See, when you are doing power 4, you're getting 4 times theta, right? And cos, sine, minus sine, cos here. When you're doing power 3, you're getting 3, right? So, like this, right? Similarly, power 2, see? 2, 2, 2. So, what should be your guess? Natural guess. So, your guess is a to the power 91 should be cos 91 theta sine 91 theta. Let me write 91 like this because otherwise it looks weird. Sine 91, maybe 1 I can write like that, whatever. Theta cos 91 theta. That is your guess, right? But you have to compute it, right? But is this 91 special? Your guest should say this should happen for every natural number, right? So what we conjecture? Conjecture means we don't know it is true or not. Conjecture for now, a to the power n should be cos n theta sine n theta minus sine n theta cos n theta, right? That is our conjecture for every n in natural numbers. So we attempt to prove it, right? Thanks to your Calculus 1 course, you have learned something called principle of mathematical induction, right? So you can prove such kind of things from principle of mathematical induction. So for n equal to 1, you have already verified. In fact, 2 and 3 also, right? So thanks to your course, which has been taken by, I guess, Professor Tejas. So you know what will happen now. So what will happen? So you assume it is true for some k. This, let's call this star. Star is true for n equal to k. What does it mean? It means a to the power k is cos k theta sine k theta minus sine k theta cos k theta. Now what you have to do? You have to show this, you call induction hypothesis, if you don't remember. I know the video is a bit long, but it will help you. My videos will be usually long. So you can fast forward it and see if you want. Okay, if you know things properly. So to show star is the statement true for n equal to k plus 1. That should be our approach. And if this is true, then our conjecture is true, right? So let us see what it is. So you know it is a into ak plus 1. Now you solve it. So cos theta sine theta minus sine theta cos theta. Cos k theta sine k theta minus sine k theta cos k theta. Multiply it. I hope you can multiply. Use the two trigonometric identities. You will get this thing. This is cos k plus 1 theta. And this is sine k plus 1 theta. Homework, huh? Although your tutors will also do this job. And the people who are watching this, you can try and ask there, of course, if you have doubts and comments. Yeah. It means by principle of mathematical induction, we are done. So you know what is a to the power 91. In fact, you know a to the power 1000. So you need not actually calculate all the powers. So what this beautiful problem says you, and I'm very happy that Professor Debergo has given such a wonderful problem. It helps you to think. It helps you to do research in mathematics. So what we have we've seen a pattern and we think it might be true. So we conjecture it, and then finally our conjecture is true. Don't think like, oh, this has been already done past several years. No, it's about how you do, how you analyze. So that's what we have to teach. Like you can, while studying mathematics, guess many theorems, definitions, and results on your own that might have done, some 100, 200 year back. That doesn't mean that it's not your research. It is also your research. Just the copyright is with someone. Okay, with this, I will end today. Thank you very much, guys.